Welcome back to Apex Instruments. We here at Apex believe that the most important thing a stack tester needs is reliable equipment. Today we're going to break down the Method 5 Isokinetic sampling train, and we're going to look at each component in more detail. First, we have the probe. The probe is the part of the sampling train that's going to be in the stack collecting the sample. We use a nozzle to collect the sample that has sharp edges that don't disturb the particles around it. Next to the nozzle is an S-type pitot. The S-type pitot measures differential pressure, otherwise known as stack velocity. As the air comes up out of the stack, the bottom of the S-type pitot measures high pressure, called impact pressure, and the top of the S-type pitot measures low pressure, called wake. As the air goes through the probe, it passes through the filter assembly. The filter assembly is a glass leak-free assembly that allows the particulate to be deposited on the filter. This is in large part how we measure the amount of particulate in the source. Then we have the impingers. In a typical Method 5 glassware setup, we have 4 impingers, all designed for the purpose of taking the moisture out of the gas before it reaches the dry gas meter. And we try to keep the temperature in the cold box down to 4 degrees Celsius, which is where water is at its most dense point and it is most likely to be pulled out of the gas. The first impinger will take out 90% of the moisture in the gas. The second impinger will take out 90% of the remaining moisture in the gas. So the first 2 impingers alone take out 99% of the moisture in the gas. The third impinger is typically empty, but if there's any remaining moisture, it will get trapped in the third impinger. And the fourth impinger is filled with a drying agent, silica gel, to make sure that as the gas passes through the system and ultimately ends up in the dry gas meter, that it's completely dry. We don't want to ruin the dry gas meter with wet gas. Next, we have the umbilical cord, which is a flexible arrangement of all the cables and lines wrapped in expandable, durable nylon. The pump that we use to pull the air from the source is a rotary vane pump. And as this section right here spins, it uses little carbon vanes to keep itself lubricated. You always want to make sure to keep your pump lubricated, otherwise it will eventually seize. Finally, let's talk about the meter console. First, we have the temperature controllers, which allow you to control the temperature in the probe and in the hot box. Next, we have the on and off switches. Then we have the timer, which allows you to do intervals during your test. We have a vacuum gauge, which determines the amount of vacuum pressure during your test. We have all the thermocouple plugs, all coded so you know exactly which plug to put where, with an indicator switch that allows you to read the temperature on this temperature display. We have all the connections conveniently in one place. The vacuum connections, the sample inlet, the pitot connections, the power in, power out, and an amp-and-all for power to your heater. We have 2 flow control valves, the coarse valve and the fine control valve. And finally, we have the incline lid manometer, which measures the differential pressure created by the velocity in the stack and the velocity of the gas that you're sampling. As the operator, it's going to be your responsibility to keep the sampling rate at the required amount based on your formula calculations to keep the test isokinetic and to keep your results reliable and consistent. Okay, that's all for today, guys. Once again, thanks for watching. Next time, we're going to talk about how to set up a Fuji temperature controller on your meter console. Don't forget to support these videos by clicking the subscribe button, and we really hope you enjoyed the video. Apex Instruments, out.